Today's lesson is 2-5, writing a function rule. And one of the things that you need to make sure that you're doing when you're writing a function rule, which is just an equation, when you're writing an equation, is to make sure you're understanding the word problem. What information are you given? What information do you not know? And what is the problem actually asking you for? So we do a lot of annotating when it comes to word problems. So highlight, underline, box, circle, any important information in the word problem, and then pull that information out and write it by referencing what your variables are. And so that kind of helps you get an idea, a clear picture of what you are trying to write an equation for. I also will substitute in symbols and numbers within the problem. So for example, of is multiply. So if I see of, I'll write a raised dot to represent multiply. Per can sometimes be multiply, sometimes divide, same with each. Is means equal to. So a lot of times when I see the word is, I'll put an equal sign. More than means add, less than means subtract. And we're going to work with less than because whenever we're writing an equation, and I'm not talking about inequalities, but when we're writing equations, if you see that a number is less than something else, you actually put that behind that something else. And I'll show you what that means in just a minute. And you can always go back and check to see if your equation is true in some instances. So let's go ahead and start looking at our examples. So example 1, A is 5 more than the product of B and 2. So it's important that you understand the terminology that is being used. So more than here signifies addition, and product signifies multiplication. And I'm not going to use an X for multiplication. I'm using a raised dot. You could even use parentheses if you wanted to. And I'm going to go plug in, annotate this a little bit more. So A is obviously an unknown. And then is here means equal to, in this case, and then 5 more than. So we're going to take 5 and we're going to add it to something. So it's 5 more than the product of two things. It's the product of B and 2. That does not mean B plus 2, but the product of B and 2. So that means that you're going to be multiplying B times 2. Okay, and of course we don't write it that way. So when we rewrite it in our final answer, we'll write it with the coefficient in front of the variable. So let's go ahead and put this down. We have A equals 5. Oops. Plus the product of B and 2. So 2B, that's the product of the multiplication of 2 and B. Okay. And so this right here is our answer. So just by annotating these simple phrases, we can easily write out the equation. All right, so let's look at the next one. Now, the next one, there was a mistake on it. If you could just put 7, or X is 7 more than, just add a little 7 there. And then the expression will make sense. Otherwise, it's an inequality, and we're not working on inequalities right now. So let's go ahead and annotate this. We have X is means equals, and then we have 7 more than. Now remember, more than means we're adding. So we're taking 7 and we're adding it to something. We're adding it to 1/3. And I don't know why this is like this, the big dash, and I think it's the font I use, but 1/3. So I'm just going to write 1/3. And of means to multiply y. 1/3 of y means 1/3 times y. Okay. So we have annotated this, and now remember, we don't use a raised dot when we write our final equation. We put our coefficient and our variables together. So this becomes X is 7 more than 1/3. third y. So a lot of times, well, not a lot of times, but sometimes with these less complex phrases, we could just write it as we read it, but that doesn't happen in all cases. So example 3, we have 10 less than 4/7 of G is H. It's kind of it's a little bit reversed from our other one. So let's annotate this a bit. One thing that you need to know is that when you have less than in a problem, you're taking the term before the less than, and you're actually subtracting it from the term after the less than. So you have to switch them. So let's look at this. Less than means subtract, right? 10 less than means that we're going to subtract 10 from 4/7 of G. Of means multiply G. So we're going to subtract 10 from 4/7 G because the less than goes behind that second term. And then, so let me rephrase, let me restate that again, just to make it, hopefully we understand that. You look at the less than, and that tells you you're going to subtract the term before it from the term after it. So let me write that. You're going to take 10 and you're going to subtract it from the term after it. So 4/7 G. Okay. So you just swap them. And then if I finish annotating, is here means equals H. So 4/7 G minus 10 equals H. Example 4 is similar. It has the less than, so that tells you that you're going to subtract the first term from the second term. But before I have you do this, quotient, I want you to think, because it's not up in my list up here and we can add it. Quotient here means, what does it mean? It means to divide. Okay. And so why don't we add that up here to our list? Quotient. And you can also say in ratio, those both mean to divide. So as you come across terms that you don't automatically know, if you want to add them to the list and you can go over them, that might be helpful. So what I want you to do is I want you to try to do this one on your own. And so if you're watching the video, go ahead and pause it because I'm going to keep going and then try it and then see if your answer matches mine. Okay. So I have 7 less than the quotient of A and 7. So quotient, that goes right here, A and 7. Now in algebra, we don't write the division sign. We write division as fractions. And so we'll do that when we write our final answer. So what you're going to do is you're going to take 7 and you're going to move it over here behind that second term. Is means equal and B. So I'm going to take the term in front of less than, and I'm going to move it to the back and subtract it from the term after less than. So let's go ahead and write that. So A divided by 7 minus 7 equals B. Now, I want to clarify something here. We have the word of in here, which you might be saying, but of means to multiply. But the way that this is phrased, it's telling you the operation is quotient, and it just, the way that we word it is that it is the division of A and 7. So in this case, of isn't referencing multiplication. Okay. So this would be our answer to example 4. Okay. All right. Next, we are going to get to example 5, and this is a little bit more complex. We're going to have to use a formula that we probably do not use very often, and it is the volume here of a cone. All right. The purpose of this example is to show you how we plug in expressions into an equation to solve for an unknown. Because we could have in here that the radius is 2 and the height is 5, and then it would be easy, right? We would just, pi times 2 squared times a third times h, and we plug that all into our calculator, and there we have it. But sometimes we have these phrases or expressions that we plug in and not actual numbers when it comes to algebra. So let's look at this. Write a function rule, an equation for the volume of a cone with a height of 5. So this is important. H equals 5. Oh, we're not done. 5 feet less than 2 times the radius. Okay, that's a long expression of the cone's base. What is the volume of the cone when it has a radius of 3 feet? Okay, let's write down the information that we have. So I'm gonna go ahead and erase this or write that out. Okay, so I'm gonna reread this. Sometimes we have to go back and reread. Write a function rule for the volume of a cone with a height of 5 feet less than 2 times the radius. Now this of just means equal. Okay, so this is saying that the height is 5 feet less than. So remember, we have less than here. So we're going to take 5, and we're going to subtract it from 2 times the radius. So we have minus 5, and then we have 2 times the radius, which would be 2r. And we're going to move that back here. So I'm going to write this right here, h equals 2r minus 5. And then they tell us that the radius is 3. Okay, so here is what we know. And it's asking us for the volume. So we have to figure out the V part of our equation. So we're going to plug in what we know into this equation. We're going to substitute it in. And I'm not going to substitute the 3 in yet. Okay, I'm just going to substitute my height in. So we have V equals pi r squared times 1/3 times my height, which is 2r minus 5. Okay. Now what I'm going to do is I'm going to plug in the 3. Now this, when you're solving problems like this, we are looking for, can you substitute in expressions like this into an equation? Then we want to know if you can solve it with a given. And here our given is the radius. So I'm going to substitute 3 into the equation. Volume equals pi. Okay, now we need to take the radius squared. So our radius is 3. So we're going to take 3 squared. And then we're going to multiply that times 1/3. And then we're going to multiply that by 2 times the radius again, which is 3, minus 5. Okay, so now we have to use order of operations to solve this. Now, I know a lot of you are just going to want to plug everything into the calculator just like it is, but I would caution you not to. You might get, you might plug something in incorrectly, and with 1/3 being a repeating decimal, you might get something a little bit wonky. So let's go ahead and start solving this. I'm going to solve my exponents first. Okay, actually, I should solve my parentheses first. So let's go ahead and do that. Pi times 3 squared times 1/3 times 2 times 3 is 6 minus 5. Okay. And yes, I'm going to go step by step. I know some of you will do some of these at the same time. So now I'm going to solve 6 minus 5. And I'm doing that to follow the order of operations. 6 minus 5 is 1 times 1. And we really don't even need that 1 there when we rewrite this again. Okay. Next, I'm going to solve the 3 squared. So volume equals pi times 9 times 1/3. Okay. And I'm going to bring this up here. Okay. So now I am going to multiply 9 times 1/3. Now that all we have is multiplication, the community property of multiplication says it doesn't matter which order we multiply it. So I'm going to multiply 9 times 1/3 because I can cancel out that 3. So I can take 3 and 9 like that. That's a 3 right there. And now I have, oh, my pen is running out of ink. Hold on just 1 second. Okay, so I'm going to write volume equals pi times 3. Now this is when I would plug it into my calculator to get a more exact answer. So let's see, pi times 3 gives me, if it doesn't tell you where to round it to, because I get 9.424777, all that, just round it to the nearest hundredths place. So my final answer would be 9.42, and then it's volume, so it's going to be cubic feet. Okay, and so that would be your final answer. Okay. All right. So if you need to stop the video and kind of go over this a little bit, make sure you understand it, please do so. Right now, we're going to move on to page 2 and example 6. And you'll notice these are all word problems because we're writing equations from word problems, or we're using formulas to solve word problems. So let's look at example 6. Write a function rule for the area of a trapezoid when base 1 is 5 inches and base 2 is 3 inches more than the height. What is the area of the trapezoid if the height is 15 inches? All right. So here is the formula for the area of a trapezoid. We have area equals base 1 plus base 2 divided by 2 times the height. And I don't know if you remember, a trapezoid can look like this, something like this. All right. Where this is base 1, this is base 2. The height would be here, and then you would divide base 1 plus base 2 divided by 2, and then multiply that all by the height. So let's go ahead and write, I'm going to actually write some of these expressions. So it tells me that base 1 is 5, and then it tells me, so base 2 means equals to 3 inches more than the height. So more than is plus, so 3 inches more than, and then I'm just going to put H for height. So here's base 2. 3 plus the height. And then it tells us that our height is 15 inches. So it looks like we have everything we need to solve this puzzle. All right. So what I'm going to do is I'm going to plug in everything except for the height, because that I want to see that formula before you start solving. So area equals, okay, base 1 is 5. Base 2 is 3 plus the height, all divided by 2 times the height. Okay. Now I'm going to plug in what height is. So let's go ahead and do that. We have area equals 5 plus 3 plus 15 divided by 2 times 15. Now, I'm gonna, because of the community property of addition, I can add all these up together. It doesn't matter what order I add them. That's what I'm gonna do first. So area equals 23 over 2 times 15. Now, at this point, I would go ahead and take 23 divided by 2 times 15, and I will get the area. Okay, so I'm going to plug that into my calculator. Oops. So we get 11.5 times 15, and that gives us 172.5. Our units are inches. And because we're dealing with area, it's in squared units. Okay. So that would be our final answer right here. All right. Let us go ahead and go to example 7. So example 7 says to write a function rule for a batch of cookies C. So the batch here is going to be referenced by the letter C. Is $15.25 plus 75 cents to package up the batch into a nice box. So every batch you buy is $15.25. You have to tack on another 75 cents to package it up all nice and neatly. Now, I taught this before, but when you write an equation, you want to write it into slope-intercept form when you have an equation like this one. And you have to look at what is actually changing. Well, the price here is changing based on how many batches of cookies you will purchase. And we don't know what the batch number is, but we know that each of these is going to equal $15.25. So that right there is our rate of change, which goes where the slope is in our intercept equation. And they want us to use C. So instead of X here, we're going to use C. Okay, and then they want us to tack on a one-time charge at 75 cents, and that is our that is our y-intercept right here. So we can go ahead and write this out as y equals $15.25 C. So $15.25 per batch of cookies plus the 75 cents to package it up. I got this question the other day. Do you put the dollar signs in the equation? And the answer is no. You don't have to have the dollar signs. And then that's all it wants you to do. It doesn't want you to solve for anything in this one. So we just wrote our equation. Okay. Let's go to example 8. Example 8 is a fun problem here, and I would really like, I'm gonna go ahead and read it, but then I really like you to think about the problem, try to set up the equation on your own just to see where you're at. And hey, if you don't get it, just continue to watch the video after you pause and try, and we'll see where you're at. So you can estimate the temperature by counting the number of chirps of the snowy tree cricket. So basically, if you want to know how cold it is outside, listen for the snowy tree cricket and count how many number of chirps it makes. And I'm pretty sure this is true in some parts of the world. I just don't know which ones. So the outdoor temperature is about 40 degrees Fahrenheit more than 1/4 the number of chirps the cricket makes in 1 minute. What is a linear function rule equation that represents this situation? Okay, so I would like for you to go ahead and try this on your own so you can pause the video. I'm going to continue going through this. So when you're ready, go ahead and unpause and listen. So this first sentence is just not information we need to create the equation. It's just background information about the problem. So it is important because now you know what you're looking at. And so now I'm going to look at the second sentence, which actually gives us the equation that we need. All right, so we have the outdoor temperature. Okay. is about, so is means equals 40 degrees Fahrenheit more than, so more than tells me that I'm going to add, and I'm going to put my 40 up here. 1/4 the number of chirps, so 1/4 the number of chirps the cricket makes in 1 minute. So we need to have a variable representing the number of chirps. So I'm just going to use C. Okay. So I'm going to write this out a little bit so we know that the outdoor temp, and sometimes this helps me to kind of understand what I'm looking at, but if you don't need to do this part, that's okay, is 40 more than 1/4 the number of chirps. So now I'm going to take this and I'm going to give the outdoor temperature is going to be T and the number of chirps is going to be C. And now I can write my equation. T equals 40 plus 1/4 C. Okay, now I have been, we've been working on slope intercept equations, and I don't think I did it on the other side. This is not in slope intercept form. So if we wanted to, we would just need to switch these around and we can write it as T equals 1/4 C plus 40. A lot of you don't like to change your variables, so you might have it as Y equals 1/4 X plus 40, and that's fine as well. I prefer to use variables that represent the unknowns in my equation just to help me understand what I'm solving for when I get to the end of my problem. Okay. Let's go ahead and go down to example 9. It says that the school cafeteria has 285 cartons of juice in stock. Each day, a total of 60 cartons are sold. What equation is a function rule that represents the amount of juice left over each day? So we want to know how much juice is left over each day. So give me 1 second. So again, I kind of like, sometimes I'll write out the equation in sentence form, shortened sentence form. So that's what I'm going to do. Here it says they have 285 cartons of juice in stock. So they're starting with 285. So start with 285 cartons. Okay. And then it says each day a total of 60 cartons are sold. Now, when you sell something, you gain money, right? But they want a function rule that represents how much juice is left over each day. Well, if I have 285 and I sell 60 cartons in one day, I have to subtract that 60 from my original amount. So 285 cartons, and each day 60 are sold. Okay. So let's look at this. We have 285. I'm going to represent cartons with C, and each day 60 are sold. So that means that's 60 here. And the $60 that are sold is each day. So I'm going to represent day with a D. Now, none of this is in the order that it should be. And so we really have to understand the difference between an independent and a dependent variable. So the number of cartons that you have, C, depends on how many days have passed. Okay, so if cartons depends on Here we go, cartons depends on days, then that tells us that C is our dependent variable, and that would go where the Y is in the equation. So C equals 285 of those cartons of juice minus 60 that are sold per day. Okay, so I kind of condensed it down into my equation. Again, this is not in slope-intercept form. So if I were to put it in slope-intercept form, which I am, I would just reverse these two terms. And remember, you want to take the sign that is in front of the term. So this becomes C equals negative 60D plus 285. And then that would be our function rule. Okay, let's move on to example 10. Okay. I don't really like to bake, but I sure like to eat these cookies. And so let's go ahead and look at this problem. Mrs. Weatherman has decided to sell her famous cookies. It costs her 35 cents to make each cookie, $2.10 for the box to hold the cookies, and 10 cents for the ribbon to tie off the box. She would like to make a profit that is 25% of her cost. Write a rule that will find what she should charge for a box of C cookies. How much would she charge for a box of 60 cookies? So we're gonna write an equation, and then we're gonna solve for the cost for 60 cookies, or the charge for 60 cookies. Okay, so sometimes I like to draw these little pictures that will help me. So each cookie, we're gonna make a little chocolate chip cookie, is 35 cents each. Okay, that's what it tells me right here. 35 cents for each cookie. Then the box is $2.10. It doesn't say $2.10 for each cookie. It's just a one-time charge for the box. Okay. Then it says, so we have $2.10 for the box. Now we have 10 cents for the ribbon to tie off the box. Now we're not going to have multiple ribbons. All right. So just one ribbon to tie off the box, and that is a one-time charge of 10 cents. And then it says here that C represents cookies. Okay. So C is cookies. All right. The other thing that it tells us is that they want to make a profit at 25%. So before we get to the profit amount, okay, let's kind of set up the equation of what this might look like. I know that each cookie right here is 35 cents. Okay, so I'm going to have 0.35 C. Then I have to tack on the box and the bow. So my box is $2.10 and my bow is 10 cents. Okay. And that is going to tell me, let's see, write a rule that will find what she should charge for a box of cookies. So that is going to represent B, what each box will cost. So I'm gonna have B equal box of cookies. You could even have it for C well, you don't want to use C because you already have C. So there we go. Now, this is how much it costs her to make the cookies. But what happens if she wants to replenish what she spent, but also make an extra 25%? And there's different ways that we can do this. So if she wants to make all of this back, that's 100% of her cost plus an additional 25%. really what she wants to make is 125%. So she wants to charge 125%. And so let me show you what that means. She wants to make a 25% profit. Okay. This has to be 100% of the cost plus an extra 25% profit. Which means she has to charge 125% of the amount that it costs her to make a box of cookies. So we're going to take this and we are going to multiply it by 125%, except when we're multiplying by percents, we need to turn it into a decimal. And we do that by moving the decimal two places to the left. So really, we're going to multiply it by 1.25. And so we'll put that right here. Okay. So here we have our equation. This is our equation right here. We did the first part. But now it asks, how much would she charge for a box of 60 cookies? Okay. So we are going to plug the 60 into the C and we are going to solve for this. So let's go ahead and do this. We have B equals 0.35 times 60 plus 210 plus 10 cents times 1.25. Okay. All right, so B equals 35 cents times 60 is $21 plus 210 plus 10 cents times 1.25. All right, now I'm going to add all of these up together. So 21 plus 210 is 2310. 2310 plus 10 cents is 2320. So we have 2320 times 1.25. Okay. And so I am going to, I'm going to do this so I don't get confused with my work. And I'm going to move this up here. And let's go ahead and calculate that out. And you should get that B equals 29. Okay. Now, you can't just write that as your final answer. What does 29 mean? What does it represent? And so your final answer is that it is $29 for a box of 60 cookies. And that is your final answer right there. So this was a two-part question, the equation and the answer to the final question. Okay. A lot of work for one problem. Of course, you may not need all of this or you don't need to write all of this down when you're doing your homework. It just kind of helps me to think through the problem. So I'm giving you different ideas to do that with. All right, let's go ahead and go to page 3. So we just have 2 problems left. So a concert seating plan is shown below. Reserved seating is sold out. Here's our reserved seating. It was $25 per seat, 10 rows, 12 seats per row. We'll figure out how much that was in a minute. Total revenue from ticket sales will depend on the number of general seating tickets sold. Write a linear function rule to represent the situation and what is the maximum possible revenue. Okay, first of all, this says that the total revenue from the ticket sales depends on, so that means that the R, the revenue, is our Y, our dependent variable, on the general seating tickets sold. So this would be like, I'd represent that by G, which is X, our independent variable. Okay. That helps me to kind of look at this and know where I might put some of these things. So our revenue equals, okay, so let's look at this for a second. I need to move this down. Okay, so this is kind of a two-parter. I'm gonna erase this for just a second. It says that the total revenue from ticket sales depends on the number of general seating tickets sold, but we also have to take in consideration the reserved seating. Okay, so let's look at each of these. First, I'm gonna look at the reserved seating. Each seat in here is $25. You have 10 rows and 12 seats per row. So in order to figure out how many seats, you have to take 10 times 12, right? That will tell you how many seats, and then you multiply it by the $25 per seat. And that will tell you the revenue from reserved seating. Okay. Then you have general seating, which is $10. So each of these seats costs $10, and you have 30 rows times 16 seats per row. Okay. Which is okay, sorry about that. So the thing is, we can figure out how much they can make in general seating, but look at the question. It says the revenue from ticket sales will depend on the number of general seating tickets sold. It tells us that reserved seating is sold out. So we can figure out how much we earn from reserved seating, but it doesn't tell us that general seating is sold out. In fact, it tells us it depends on how many seats they actually sell in general seating. So maybe they won't sell out. So they want us to come up with an equation that would represent this, and then later on figure out how much revenue they made based on the number of seats. So in this case, since we don't know how many of these seats were sold out, we're going to represent this by 10G. Okay, for general, we chose G for general seating up here. Okay, so we can use all of this information to come up with an equation. So we have R for revenue is going to equal the reserved seating, and we know that they've sold out. So 10 times 12 times 25 plus the amount that they sold in general seating. And we don't know how much they sold in general seating. So let's simplify this a little bit. R equals 10 times 12 times 25 is 3,000 plus 10G. And I want to write this in slope-intercept form. So I'm going to rearrange this. R equals 10G plus 3,000. So let's go over this equation really quick. We know that reserved seating is sold out, so they've already made $3,000 in revenue. They're selling general seating, but we don't know how many seats they've sold, but we do know that it's $10 per seat. So we're going to add $10 per seat of general seating, but our unknown is the G, the number of seats. So we've created an equation. We've written a linear function rule to represent the situation. So we did this part. But then it says, what is the maximum possible revenue? Well, that would mean that the entire stadium is sold out. So here, if the whole thing were sold out, it would be 30 rows times 16 seats per row times $10 per ticket. Okay, so let's go ahead and plug that in here. It would be the revenue equals, they already have the 10 there, so 10 times 30 times 16 plus the 3,000 from the reserved seating. Okay, so now we're just gonna solve all this. So 10 times 30 times 16 is 4,800 We tack on the 3,000. R equals 7,800. So total revenue or total max revenue is 7,800. Don't forget your dollar sign. Okay. There we go. Okay, let's look at this last one. A plumber charges a service fee of $40 plus $25 per hour for labor. Write a function rule for the cost of hiring a plumber for a job that takes 8 hours. How much would it cost to hire a plumber for a job that takes 4 hours? So this is a two-parter. You're going to create a function rule, and then you're going to figure out how much it would cost to hire a plumber for 4 hours. This one I want you to do on your own. I'm not going to walk you through it, so I'm going to pause the video. And then in just a minute, I will unpause it to give you the answer and you can check your work. Okay, go ahead and check your work and make sure you understand it. And that does conclude lesson 2-5, writing a function rule.